Classifying triangles and angle relationships. There are two ways to classify a triangle, by its sides and its angles. By its sides, we have the Isosceles Triangle. The Isosceles Triangle has two equal sides and, as we'll discover in a minute, has two equal angles. Isosceles means a triangle that has two equal sides. An equilateral triangle has two equal sides and three equal angles. A scalene triangle has no equal sides and no equal angles. Classifying a triangle by its angles, we have an acute triangle. That means all angles acute, meaning they're all less than 90. Both of the examples I drew for the equilateral and isosceles were acute. An acute triangle has three equal angles. An obtuse triangle has one obtuse triangle. Here we have an obtuse triangle. That angle there is greater than 90. That is also isosceles. A right triangle would have one right angle. This is an example of a scalene right triangle. An equiangular triangle, a triangle with all equal angles, turns out it also has all equal sides. It turns out that an equiangular triangle, which is also equilateral, has three 60-degree angles. And this is because, as we'll discover in a moment, of the Triangle Sum Theorem. All the angles in a triangle add to 180 degrees. The Triangle Sum Theorem is something we use a lot. You have to know that the sum of the angles in any triangle is 180 degrees. Here's how we know that. Take any triangle and take one of the vertices and draw a parallel to the opposite side. If we put some numbers in there to represent the angles, notice that the measure of angle 4 plus the measure of angle 2 plus the measure of angle 5 is 180 degrees, because this is half of a circle. Remember that I drew in this line parallel to this line. So this angle and this angle, 1 and 4, are alternate interior angles. Angle 3 and angle 5 are alternate interior angles. So 1 is the same thing as 4. And 5 is the same thing as 3. And we can see that the three angles in any triangle have to be 180 degrees. Let's put some numbers in there. Maybe that'll make it easier to see. Just making up some numbers for an example. If this angle was 100 degrees, this angle was 50 degrees, and this was 30 degrees, notice that no matter what, these three have to add to 180 because they make that straight line. Because the line in blue was drawn in parallel, this angle and this angle are alternate interior. It would have to be 50 degrees. And this angle and this angle are alternate interior. It would have to be 30 degrees. And we can see the 50 and the 30 and the 100 sum to 180 degrees.
Because the angles in any triangle sum to 180, this implies a couple of things. First of all, remember that an equilateral triangle is the same thing as an equiangular triangle, and because of the Triangle Sum Theorem, we know all the angles are 60. 180 degrees split evenly among three equal angles ends up being 60 degrees. They all have to be 60 in any equilateral triangle. And a triangle at most can have one obtuse angle and one right angle. If you have one obtuse angle, that's an angle greater than 90. You couldn't have two of them because that would make more than 180. And if you had a right angle, you couldn't have two of them because two of them would make 180 degrees and you'd have nothing left for the third angle. You can have at most one obtuse and one right angle in any triangle. The Isosceles Triangle theorem says that if two sides are congruent in a triangle, then the angles opposite those sides are congruent. I mentioned earlier that an isosceles triangle has two equal sides and two equal angles. Those equal angles are always opposite the equal sides. Note that if they give you the top angle and they say it's 40 degrees, that you can find these two angles because you know that the 3 add to 180. So basically what you're going to do is say 40 plus the other two angles equals 180, which means 2x would equal 140, and divide by 2, x would be 70 degrees. So what we did was take 180, subtract the 40, and split it among the two equal angles. And that's how we got 70 degrees. And here are the last two things. The exterior angle of a triangle is an angle formed by one side of the triangle and an extension of an adjacent side. So if we take any side and extend it, this angle right here is called an exterior angle. It's formed by the extension of a side and one side of the triangle. Notice that if I extended the other side, that these two angles, both exterior angles, end up being congruent because they're vertical angles. The exterior angle theorem says that the exterior angle of a triangle is equal to the sum of the two remote angles. Here's why. Remember the Triangle Sum Theorem says that the three angles in a triangle, in this case angle 1, 2, and 3, angle 3 and angle 4 add to 180. Notice that both these expressions contain angle 3, and notice that what is being replaced is angle 4 with 1 and 2. Turns out then that the measure of angle 4 is equal to the measure of angle 1 plus the measure of angle 2. Notice the way the theorem is worded. The exterior angle, that's the outside angle, is equal to the sum of the two remote angles, the angles furthest away. The measure of 4 is equal to the measure of 1 plus the measure of 2. Here's an example with numbers. If the two remote angles were 30 and 80, then this exterior angle would be 110 degrees. These next questions are examples from your assignment. Classify the triangle by its angles and sides both. Mark the best answer from each column. Notice that all angles are 60. That means it's equiangular, also equilateral. It's equiangular and equilateral. Another example. Classify this triangle by its angles and sides. This angle is greater than 90. That makes this obtuse. Notice that there are two equal sides. That makes this also isosceles. This triangle has a 90-degree angle, so it's a right triangle, and two equal sides. That makes it isosceles. The Triangle Sum Theorem says that these three angles have to add to 180 degrees. You could do this a couple different ways. You could just go 180 minus the two angles, 57 and 92. You could also treat this like an equation. Call this angle x. X plus 57 plus 92 equals 180. That's x plus 149 equals 180. So x would be 180 minus 149 because you have to subtract 149 from both sides. Which means this was 180 minus 149. So either way, you get 31 degrees. In this one, you are going to want to make an equation. X minus 16 is my one angle, plus 63, the other angle, plus 78. The three angles add to 180. Simplify. X plus 125 is 180. Subtract 125 from both sides, and the result is 55. Notice that this is not 55 degrees. It's x we're finding. X was not an angle, it was just a variable. Here we have to recall corresponding angles. Notice the parallel lines. This angle and this angle are corresponding angles. So we immediately know that angle 2 is 75 degrees. I know that the measure of angle 3 plus 88 plus 75 would equal 180. So the measure of angle 3 plus 163 is equal to 180. Subtract 163 from each side, and the measure of angle 3 is equal to 17 degrees. Notice that 75 degrees and angle 1 are a linear pair. Those two angles add to 180. So I can just take 180 and subtract 75. That's 105. And I know that angle 1 is 105 degrees. On question 27, in order to find x and y, I first need to find this missing angle. I know this angle, the 34 degrees and the 77, would add to 180. So I'll call this angle A. Angle A plus 34 plus 77 is equal to 180 degrees. So angle A plus 111 equals 180 degrees. Subtract 111 from 180. The result is 69 degrees. So this angle is 69 degrees. Let's erase that. Now these two are a linear pair, so they add to 180. So y would be 180 minus 69. 180 minus 69 is 111. Now, I just noticed something. I did this the hard way. Angle y is an exterior angle. It's equal to the sum of the two remote angles. Notice that 34 plus 77 is 111, and that's what y ended up being. Now that I know this is 111 degrees, x plus 111 plus 48 is equal to 180. In other words, the three angles in this triangle add to 180 degrees. Simplify. X plus 159 is equal to 180. Subtract 159 from both sides. The result is 21. More triangle sum questions. Why 82 and 56 all add to 180? Why plus 138 is equal to 180? We subtract 138 from both sides, we get 42. So y is 42 degrees. Now that I know y, 38, x, and y, which was 42 degrees, all add to 180. X plus 38 plus 42 equals 180. 38 and 42 add to 80. We subtract 80 from both sides, we see that x is 100 degrees. Now we know that 38, 125, and w make 180. Simplify 38 and 125, and x plus 163 is 180. If we subtract 163 from both sides, we get 17. 17 degrees is what w is. On question 30, the easy way to do this is with the exterior angle theorem. I'm going to point out you don't have to use that though. You could take 180 minus 39 minus 33, and that would give you this angle right here, which ends up being 108 degrees. And then you could find that at x by subtracting from 180. But notice that the exterior angle is equal to the sum of the two remotes. The exterior angle is equal to the sum of the two remote angles. So x is 39 plus 33. Well, that's 72 degrees. On question 31, you could use the Triangle Sum Theorem because we know that these two add to 180. So this one would be 106 degrees. And then I know that x, 106, and 34 equal 180. That's the Triangle Sum Theorem. But I also know that the exterior angle, which is 74 degrees, is equal to the sum of the two remotes. Subtract 34 from both sides, and I can see that x is 40 degrees. On question 34, it'd be nice if the picture was a little bit bigger. But notice the isosceles triangle. This angle and this angle are the same angle. Well, I can see that I have a linear pair, 110, and the angle I've marked in black add to 180. So that means that 180 minus 110, that's 70 degrees, is that angle right there. And because this triangle is isosceles, angle 1 is also 70 degrees. Now, if we subtract from 180, 180 minus 70 minus 70, that's going to give us this top angle right up here. 180 minus 140 gives us 40. And we have vertical angle, so this angle is also 40. Well, I know the measure of angle 3 plus that 40-degree vertical angle plus the 90-degree angle is equal to 180. 90 and 40 is 130. We'll subtract 130 from each side, and the measure of angle 3 is 50 degrees. Now, the only one we don't have is angle 2, but we know that we have a linear pair. Let's change colors. From here to here is a linear pair, and this angle's 40. So 180 minus 40 gives us angle 2. That's 140 degrees. This one's like the example I did in the teaching. 2x, those two angles, plus the 39 is 180. So 2x would equal 141. If I divide by 2, I get a decimal, 70.5. This one is asked in a different way, but it's the same as the last question. These two sides are equal. That makes these two angles equal. If you call them x, then that means 30 plus 2x is 180. Subtract 30 from each side. 2x is 150. Divide by 2, x is 75. So 75 degrees. Here's an equilateral triangle, which is also equiangular, which is what you got to know here. That means that 3x, 5x minus 40, and 2x plus 20 all equals 180. So that is 10x minus 20 equals 180, which is 10x equals 200. Add 20 to both sides. Divide by 10, and x equals 20. Now I want to point out I added the three angles and set them to 180, and that works, but there was an easier way to do this. An equilateral triangle is also equiangular, and if the three angles are equal, 180 divided by 3 is 60. All these angles are 60 degrees, which means we could have just said, for example, 3x equals 60. Divide by 3, and we get x is 20. Each angle is 20 degrees, and x is 20. Last example. Here you need to use the fact that an isosceles triangle has two equal sides and two equal angles. Remember, the isosceles triangle theorem said that if two sides are equal in a triangle, then the angles opposite those sides are equal. Since this side is equal to this side, these two angles are 54, which means I can find this angle by subtracting from 180. 180 minus the 54 minus the other 54 will give me that third angle, which is 72 degrees. Now I could have also used the fact that this angle, I'll mark it in blue, is an exterior angle, and it's equal to the sum of the two remotes. Or I could do what I'm doing right now and say these two angles are a linear pair, so they add to 180. 180 minus 72 then will give me the angle I've marked in blue. But that angle marked in blue is an exterior angle to the triangle that has the 254. This angle right here is going to be 108 degrees. The triangle with angle 1 in it is isosceles. These are the two equal sides. So this angle and this angle are congruent. I could call them x, and I know that 108 plus x will equal 180. So 2x plus 108 will equal 180. Subtract 108 from each side, and 2x will equal 72. Divide by 2, and x is 36. So the measure of angle 1 is 36 degrees.